Picture June 1945, but the map of the world is completely drawn by the Axis powers. Nazi Germany has an iron grip on Europe, and a mushroom cloud has just risen over an American city, dropped by Japan. We don't read about this in textbooks because history is authored by the surviving side. We are taught the Manhattan Project was a solitary, inevitable triumph of American science, comfortably ignoring how dangerously close the United States came to losing the nuclear race. The reality is that Allied supremacy wasn't guaranteed by sheer brainpower. The outcome of the Second World War hinged on a fragile sequence of enemy blunders, stolen secrets, and a few desperate acts of sabotage. By the early 1940s, the German military had already assembled a formidable brain trust. Under the direction of theoretical physicist Werner Heisenberg, they had a clear mandate: build an atomic weapon. The physics presented a massive hurdle. To sustain a nuclear chain reaction, you have to split uranium atoms using neutrons. But these neutrons naturally fly around entirely too fast to split the uranium effectively. You have to insert a moderator, a physical speed bump to slow the neutrons down so they can actually hit their targets. Heisenberg's team narrowed their moderator down to two realistic options. They could either use a massive amount of highly purified graphite or a rare isotope-rich liquid known as heavy water. The path they chose right here would set the trajectory for the entire war. The German military assigned their top experimental chemist, Walter Both, to test the graphite. He concluded it was practically useless as a moderator. But Both made a critical error. The graphite he tested was contaminated with microscopic traces of boron, which completely ruined the experiment. Trusting his results, the Nazi regime completely abandoned cheap, plentiful graphite. They bet the entire future of their nuclear program on procuring heavy water. Meanwhile, across the Atlantic at Columbia University, Enrico Fermi and Leo Szilard were running the exact same tests. They discovered that if you clean the graphite so it is absolutely pure, it works perfectly. Recognizing the danger of this knowledge, Leo Szilard essentially formed a scientific pact. He convinced his colleagues to stop publishing their atomic research in public journals, initiating a strict information blackout so that not a single paper would tip off Hitler. By keeping the truth about pure graphite hidden, the Allies locked Germany out of the easiest route to a bomb, forcing them to rely entirely on a liquid that was incredibly difficult to produce. That forced reliance brought the entire German nuclear effort to a single vulnerability: a hydroelectric fertilizer plant nestled deep in the mountains of occupied Norway, which produced heavy water as a byproduct. The Allies knew its value. Before the Nazis even fully secured the region, French intelligence agents managed to smuggle out the plant's existing stockpile of heavy water, flying it right past German fighter planes using decoy aircraft and fake canisters. But the plant kept producing, so the British military launched Operation Gunnerside. In the freezing winter of 1943, 9 specially trained Norwegian commandos scaled a 200-meter cliff in the dead of night, infiltrated the heavily guarded fortress, planted explosives on the machinery, and vanished. Unwilling to give up, the Nazis tried to move whatever heavy water they had left back to Germany aboard a transport ferry called the SF Hydro. Resistance fighters managed to sneak aboard and plant a time bomb, sending the ship, the heavy water, and tragically, several civilian passengers to the bottom of a frozen lake. Saboteurs in the freezing Norwegian mountains physically dismantled the Nazi nuclear program before their physicists could ever reach the finish line. Yet Germany wasn't the only threat. The Japanese Empire had their own brilliant physicists who understood exactly how to build a bomb. Their only missing piece was the raw fuel, uranium. In a desperate final handoff in April 1945, Germany loaded a massive submarine, U-234, with V-2 rocket technology, jet engine designs, and 500 kilograms of enriched uranium, and sent it toward Japan. But Germany officially surrendered while the submarine was still in the middle of the ocean. Upon hearing the news, the German captain decided to surrender his vessel to the U.S. Navy, while the 2 Japanese officers on board quietly took cyanide rather than become prisoners. That mid-Atlantic surrender severed Japan's final lifeline. The Axis powers were officially out of raw materials, clearing the entire board for the United States. But the Manhattan Project had a closely guarded problem of its own. Despite their massive funding and industrial might, American scientists were struggling to enrich enough uranium in time to actually build their weapon. This is where the historical record gets murky. According to the extensively researched book Critical Mass, the U.S. military didn't just lock away the 500 kilograms of uranium captured from the U-boat. They secretly processed it and used it as the very fuel for the bomb that would soon be dropped on Hiroshima. If that submarine had managed to evade capture and deliver its payload to the Pacific, the Japanese military would have possessed the exact fuel they needed to finish their own weapon. Instead, the fuel intended to empower the Axis was weaponized against them, resulting in the terrifying devastation that actually unfolded, ending the war. The history of these weapons is often presented as a clean narrative of American scientific dominance. But the reality is far more fragile. A sequence of events shaped by a tainted graphite sample, a few commandos in the snow, and the intercepted secrets of a collapsing empire.